Continuing lesson 4.7 on subtracting expressions. If we look at example 1, this one we saved back because it's a little bit more happening than some of the other ones. We have to actually set things up here, set up an expression. So example 1, Lita's family wants to put a tiled border around their swimming pool. What expression represents the total area of the border? So we want the area of the border. So you can look at the picture here. And see what's happening there. Basically, what we're going to do on this problem, it's kind of like we're going to make a rectangular donut, if you will. So, you know, the idea is we're taking some rectangle. You know, if we include all the way around the outside of the border, if we take that big rectangle, and then we subtract out the area of the pool, that's going to give us that border area left. Okay, so it's like that whole thing, including the border, and then we subtract out the pool part, and then that's going to just leave us the area of the border. Okay, so that's what they're doing over here. So if you look, we had 2x plus 14 was the length of the pool, and then the border is 2 feet on each side. So 2x plus 14 plus 2 plus another 2 altogether gives us 2x plus 18. And then going across, the width of this is 14, and then we add a 2 and we add another 2, would give us 18 as the width. Okay, so 2x plus 18 by 18 are the dimensions of this whole thing. So that's what they're doing here. That's the area of the pool plus the tiles. That's that whole big rectangle would be 18 times the quantity 2x plus 18. And then we're going to subtract the area of the pool. So we're going to subtract 14 times 2x plus 14. So in order to do that, we are going to need to distribute. So we distribute here, 18 times 2x is how they got the 36x, and then 18 times 18 is how they got the 324. This next part, they're subtracting. You may want to add the opposite because we need to see this as distributing a negative 14. So this is like plus negative 14 times 2x would be negative 28x, and then plus negative 14 times 14 would be plus a negative 196. Once we get to that point, we're just going to combine like terms. So 36x plus negative 28x, you guys can go straight to it. And the answer section there would be 8x. And then 324 plus negative 196, they are working against each other. You subtract those and you'll get 128. So 8x plus 128, again, that's taking the whole thing, subtracting out that pool part in the middle is just going to leave us the area of the border. So the area of the border would be 8x plus 128. So key concept, again, different than what we did on example 3. Example 3, we actually had a number next to what we were subtracting. If you don't have a number there, remember, you can put a 1 there if you want and think of it as like we're distributing negative 1. Or you can just add the opposite, just change your signs there. So we're going to look at the do you know how number 4. So number 4, part A, they're asking us to subtract. So one option here is that you can put a 1 there and then think about this as distributing a -1 into the parentheses. So that would be -1 times -16 plus -1 times 7x, or the other option is adding the opposite, just changing the signs, everything in the second set of, or in the set of parentheses there. So if we did it this way, we got the 21x. Negative times negative would be a positive 16. And then negative times positive would be a -7x. And then we can combine our x's together, and that would be, 14x plus 16. And again, same idea over here. If you would be doing the same thing, combining like terms, you would get the same answer, 14x plus 16. If we look at part B, same idea. So you can either put a 1 and distribute the -1, or you can add the opposite. So if we choose the option putting a 1 here and then distributing a -1, probably would be a good idea to add the opposite inside the parentheses there. So we've got -1 times 17 and -1 times -5n. So -1 times 17 is -17. -1 times -5n would be a positive 5n. So at this point we're looking for like terms. We have a -13n plus 5n. Since they're opposite signs, they're working against each other. So if you subtract those, subtracting those would be 8. We have more that are negative, so that would be a -8. So -8n minus 17, or if you had that as -8n plus -17, either of those would be correct. We look at part C, same idea. So for this problem again, if you prefer, we can put a 1 here and distribute the -1. Inside the parentheses, probably not a bad idea to add the opposite so you keep your signs straight. So we do -1 times y, -1 times -7. So -1y, negative times negative would be a positive 7. And then we can combine like terms. This plus sign here, by the way, I just kind of tend to add that in. If I did it this way, I normally would do actually the adding the opposite thing, but if I did it this way, I would probably add the opposite over here and make that plus -1. If that helps you then to see that. And you don't have to have that plus sign there. If you just have -1 times y with no plus sign in between, that'll come out the same. Okay, it's just that on the next step you'll have -1y, and then you might want, potentially want to add the opposite so you can see that as a -1y. So then combining like terms, 4y plus -1y is 3y. -7 plus 7 is 0. You can put plus 0, but that's not going to change anything, so we could just say 3y is our final answer for part C. If we look at part D, similar idea here. In the first set of parentheses, you might want to put a 1 next to the W. Second set of parentheses, if you go ahead and add the opposite, and also maybe put a 1 here. So we've got the choice again. Majority that we're working with right now prefer they just multiplying by -1. I'm going to just go through one more time just to show you your other option is adding the opposite. So adding the opposite, whatever. We change subtraction to addition, and then we're just doing the opposite of everything in the parentheses, in that second set of parentheses, okay? Again, if you don't prefer that method, if you distribute that -1, then you should be up to this point after you do your distributing part. At that point, we can look to combine like terms. So -1W plus 1W, those are actually going to cancel. Just like if we did -1 plus 1 is 0, -1W plus 1W is 0W if you want, but 0 times anything is just 0. So we really don't even need to put that. We can just say those canceled out. And then 4/10 plus 4/10, which would be 8/10. So 8/10 would be our answer for part D.
So for that one.
So look at number 5. Jude has 5 pairs of sunglasses that cost the same in his online shopping cart, but then decides to get only 2. Each pair of sunglasses is the same price. Let P represent the cost of each pair. Write an expression for the original cost, the updated cost, and the difference in costs. Okay, so he has 5 pairs of sunglasses, and then he decides to only get 2. P is the cost of each pair. So 3 different things they're asking us to write. So first of all, we're going to write what our original cost is.
Wait, when he has 5?
So the original cost, which would be with the 5 pairs that he was going to get, it'd be 5 times P, because it's P is the cost of 1 pair. And then if you'll notice, if we buy at least 3 pairs, the shipping is $1.49. So 5P plus $1.49 shipping, that would be the original cost with the 5 pairs. Then we're going to look at the updated costs. So the updated cost is now that he's deciding just to get 2 pairs. So for that would be getting 2 pairs, so 2 times P. Now this shipping, we didn't buy at least 3 pairs of sunglasses, so the shipping now instead is $6.49. Which sometimes these deals like this don't seem to make sense. Like, you know, they're shipping less things. Why are they making us pay more? It's just to try to get you to buy more stuff, basically. Okay, kind of like you spend $100, you get $10 off, or deals like that. If you don't need the stuff, it's not really a better deal, even though you're quote-unquote saving money. So then, to find the difference in costs, difference would mean that we would be subtracting these. So what they're wanting us to do maybe is to do the original cost minus the updated costs. You might try to get around this, but this might be our best bet, actually doing it this way, potentially. If you want to put a 1 here, you want to distribute the -1. We got 5P plus 149. This would be -2P. -1 times 649 would be -649. and then we can combine like terms. So 5p plus negative 2p would be 3p. 149 plus negative 649. Those are different signs, so we'd be subtracting those. So if you subtract those, is right at $5. The deal is, though, we have more that are negatives. So this would be a negative 5. So 5p plus negative, 3p plus negative 5 or 3p minus 5 would be actually our expression. You could try to get this just by subtracting, like saying, well, 649 minus $1.49 is 5, and then 5p minus 2p is 3p. But then you might think the answer is 3p plus 5. It's actually, if you think about it, right here, if you're subtracting, you're taking the original cost minus the updated cost, so you're actually subtracting more than what you have. So it's like $1.49 minus $6.49. Well, we can't really do it that way, so you can say add the opposite, whatever. But basically, it boils down to what we ended up doing here, where we had different signs we had to subtract, but then we had more that were negative.